The last video of this chapter will introduce you guys about the dynamic harmonic regression and how the people use the loss predictors in a dynamic regression model. So the first part 9.5, when we talk about the dynamic harmonic regression, we already introduced about the ARIMA and the ETS model, which one can be used to deal with the seasonality array. However, there's some drawback. Why the ETS function will restrict the seasonality can up to maximum to 24, like 24 hours per day. The ARIMA model, they can do it a little bit better when they allow for the seasonal periods up to like 350 in the seasonality. However, normally with the regular computer, we usually run out the memory wherever the seasonal periods in more than 200. So that introduce another problem we have to address when we have to find out some problem, some kinds of new methods and approach that can deal with more and higher range of seasonality. And that's why people come up with the idea of the harmonic regression approach. And they do it using for the Fourier term in the short-term time series dynamic that can help to handle it. And this will be all the thing we can see about the advantage of using the Fourier term in the ARIMA model. And you can take a look at over here. Basically, you have learned about the Fourier term in like the term of geography, algebra, and also for the calculus. And this is the term for us to apply it in this kinds of model. Basically, we have the sine, we have the cosine, and we have the harmonic seasonalities of the time series. And you can see it how we can measure all the thing over here. I will not spend too much time to talk about the model and also for the like basic mathematical principle behind this one because we don't have time. But we go into the example number 1. And I will demonstrate you guys very quick on the RStudio. Okay, so we want to use this for applying the section 9.5 dynamic harmonic regression, and we apply the demos on the AUS coffee datasets. And if you have not remembered about what exactly they are, so AUS coffee, that should be the expeditor of the eating now in Australia monthly data from the April of the 1982 into the September of the 2017. And we can take a look into the structures of the AUS. Okay, coffee, cafe. Okay, and also we can see the head of them, AUS cafe from April 1982, right? We also have to plot the data with the autoplot function, and we use this on AUS cafe. This is how it looks like. Okay, seasonality and also the trend up and also the variant in the fluctuation. That's something that we can easily find in from the time series. Okay, now the thing would be like I would just use the data for the sub window from 2004 only. I did use the window function to just select it from 2004, and then I apply for the autoplot for one more time. You can see that we can ease out the problem of the fluctuation in the variant. Okay, now even when we still have the seasonality problem, even when we still have the problem of the seasonalities and the trend up, but it still look a little bit better. Now I'm going to use this for a better function. Create a plot, a loop to select the model. Okay, so first of all I plot by list to clean it out, and then I create for a function of loops from I into the sequence of 6 different variables. Later on, I will show how you can conduct them all by individually. But in this way, I show you out like how we can do it in a system by creating for function. I create a function fit for auto arima when at the same time I regress them in the theory of the cafe, but the different case from 1 into the sequence of 6. Alright, and seasonality, the width can be the fold, we go into fold and lambda into fold 0. That means we don't transform the data. Later we plot the data and we want to create this one into this function. It can take for a while for to running everything out, but basically I want to see the forecasting result, and at the same time in the x level I want to see what will be the harmonic regression will be the best one into the route. Okay, and now with this I'm going to just plot everything into one single function. Okay, I will plot all the model or the harmonic, if you want to say harmonic model, in one single plot. Okay, so I want to have a lot 1 2 3 4 5 to 6, and number of row will be 3 and number of columns will be 2, and in that way I can generate for all the results at the same time. You can see this one will be the first model, the second when k equal to 2 and up into k into 6, and up over here if you take a look into all the characteristic key information, you can easily find that the model number 5 when the k equal to 5, they represent the best model with the highest accuracy. Right, that will be how the thing has been done by me. At the same time, over here I have a prepare for another coding, and if you have the time you can stop your video over here and take a look how this work. Basically I create the 6 different model, right? And for each of them I change for the k from 1 into 6, and I run that at the same time, and then I create the combination and plot them all the thing into one single one, and that's be how the thing can go on. You can do it at the same time if you want. Thank you so much for your attention.